Hi, I'm Imani Steele and welcome to Distraction News, where I'll give you the news and ask you 5 questions on what I've reported on. But be careful of distractions or you'll get, well, distracted. This just in. Hot topic that's been circulating for years. Ink printing. And I don't just mean in the office, but science lab. And what kind of ink are they using? Bio ink. Yes, that's right. Ink that can be made to form not words, but living tissue. Scientists in the Fraunhofer Institute for Interfacial Engineering and Biotechnology in Stuttgart have succeeded in developing suitable bioinks for this printing technology. The bioink maintains a stable cell suspension, preventing the settling and aggregation of cells that usually impede cell printing, whilst meeting the stringent fluid property requirements needed to enable cell printing even for many novel commercial inkjet printheads. The printers at the lab in Stuttgart have a lot in common with conventional office printers. The main difference is the number of jets and tanks is smaller than in the office counterpart, as well as the heater on the ink container, with which the right temperature of the bioinks is set. The researchers have commercially modified the gelling behavior of the gelatin/ink to adapt the biological molecules for printing. Instead of gelling like unmodified gelatin, the bioinks remain fluid during printing. Only after they are irradiated with UV light, they cross-link and cure to form hydrogels. These are polymers containing a huge amount of water, just like native tissue, but which are stable in aqueous environments and when being warmed up to physiological 37 degrees Celsius or 98.6 degrees Fahrenheit. The researchers can control the chemical modifications of the biological molecules so that the resulting gels have differing strength and swelling characteristics. The properties of natural tissue can therefore be imitated from solid cartilage to soft adipose tissue. Though there is still a need to learn a fair amount about the interactions between the artificial substances, cells, or natural tissue. The biomolecule-based variant in the bioink provides the cells with a natural environment instead, and therefore can promote the self-organizing behavior of the printed cells to form functional tissue models. Cell viability was assessed by fluorescent live and dead staining using calcium Am and prommodium iodide. The live dead cells were manually counted and the result provided significant viability. The cell proliferation and dedifferentiation was also assessed with NTS colorimetric assay, omega, and changing the cell media in concentration over periods of time. 5% concentration of fetal bovine serum in the first 24 hours, and then reduced to 2% fetal bovine serum in the 48 and horse serum after 72. This too yielded significant proliferation and differentiation. This innovation in printing technology may pave the way for biofabrication of multicellular structures and functional tissue, and eventually fully functioning organs. The big challenge facing scientists at the moment is to reduce vascularized tissue. This means tissue has its own system of blood vessels through which the tissue can be provided with nutrients. If we can do this, then the wait list for patients in need of organs would dramatically decrease. This has been Distraction News.
Hi, this is Jada Cole, and this is quiz time. Were you listening, or were you distracted? What is the main difference of the bioink printer and the regular printer? The tanks, the printer, or the temperature? It's the temperature. What is the consistency of the bioink? Gel, fluid, or solid? If you said it was the gel, you're absolutely wrong. The answer is fluid. How do they form gels? UV light, black light, or fluorescent light? The answer is UV light. Using what serum was differentiation determined? Casein AM, Ketobovine or promega? The answer is ketobovine. What is the next step for bio? A. Avascular tissue. B. Whole organism. Or C. Vascular tissue. If you said A, you're absolutely wrong again. The answer is C. Vascular tissue.